test the other day. I can show you that one again. You are going to have a 13 question, okay? And you're going to answer 12. And these are going to be the topics that you are going to get 1 or 2 questions from each. Okay, so we would like you to evaluate, double integral and triple integral. So directly we give you 1 from each. Okay, that would be a straightforward, but make sure you don't make any mistakes, like the one that was on the test. Test 3, question number 1, a number of you missed it. So it's going to be again like exponential one, trigonometric one, double check that one, okay? So this is going to be one question. The other one's going to be polar form. You double integral, you change it to the polar form and you just do it. Again, is in like test 3. Then you have one question on the reversing the order. Okay, again, test 3, you know that you just get the reverse order from the type 1 region type 2 and just change it. So that was the one. Volume problem. We give one volume problem. It can be done either with a double integral or triple integral. Then you are going to have a triple integral that you have to change it to the cylindrical coordinate. A triple integral that you have to change it to the spherical coordinate. Okay, then we give you one question on change of variable or substitution method. Again, check the solution. Some of you missed it on test 3, especially when you want to go from the XY coordinate into the UV coordinate. Then you just get the image of the vertices or partition points or the corner points. So if you made a mistake on this one, just check it again. It's going to be a straightforward, can be done quickly. Okay, the problems are short, they are not complicated. So it can be done because your time is 2 hours only. Then we give you one question on line integral. It's just ordinary one, f dot dr. You identify the r of t and just do it. One question, Green's theorem. These are going to be quiz 4. Okay, line integral quiz 4. Then one question on the Green's theorem. Then you switch the line integral to double integral and do it. Then we are going to give you one question that you decide about the independent paths of, in the case of the line integral. That this is where you check to see if your force is going to be conservative. If the force is going to be conservative, so the integral would be independent of lines, like in the quiz 4. And when it's independent, so we can pick the easiest path. So the endpoint would be just the endpoint, and you evaluate your integral using the fundamental theorem of calculus for the line integral. We give one question on surface integral. These are the challenging one that takes a little bit more time to do. Okay, and this surface integral, you have 2 cases. You may have the scalar one. Okay, so the function would be just f of x and the y, and the parametric equation of your curve is going to be just a function of x and the y. So that parametric equation is already solved for z. So that can be done quickly, but the resultant integral can be challenging. And the other one is going to be surface integral when you want to do it for the vector fields. For the vector fields would be the same that you do for the verification of the Stokes theorem, okay? So these 2 takes times, that the surface integral, verification of the Stokes theorem, or the surface integral and vector fields. So read through the problems on the test. There are some of them straightforward. All of them are kind of short. So some of them are very straightforward. Just do it first. Then keep those like the surface integral or the verification of the Stokes theorem. These are going to be the one that you better keep it for the end, or the change of variable. But the rest can be done, in a matter of 5-6 minutes for each question. Okay. So no surprises, 13 questions, 13 topics, and you answer 12. So that would be the organizations. So basically test 3, quiz 4, that's it. Okay. And we are not going to give anything regarding the divergence theorem, but if you use it, you are, you're fine. You can do it, but play it safe. Just stay with the menu, and then you'll be fine. Okay, and we tested this one several times before, and the people won't have really difficulty to do it. The difficulty is always time. So manage your time, okay? Manage your time, start with the shorter problems, then you'll be fine. Okay, so quickly over those questions on the quiz first, because there are some points to make sure that everybody know it. So all the line integrals can be done, most of them by checking the conservative force, but not if it's going to be directly given to you, and that's a question. So that's quiz 4. Okay, quiz number 4. And the first part is a line integral problem. Okay, that's a line integral problem. You can consider it at that category that I'll talk about it. So the question is going to be, you want to evaluate this integral. Okay, you want to evaluate the integral. It's a line integral of x plus y squared divided by the square root of 1 plus x squared on the C, where your C is going to be a connection, a combination of two curves. So the curve C1, okay, the curve C1 is a straight line. Okay, it's going to be line segment. This is a line segment from the point 1, 0 to the point 1 and 1/2. That's easy to create it. And the C2 is going to be along okay, so this is going to be a part of, okay, it's a part of the parabola y equal to the 1/2 of x squared from okay, from the point 1 and 1/2 to the point to the 0, 0. Okay, that's going to be your case. So it can be done easily. So the solution is going to be, you break it into two parts. Okay, so your integral is going to be break into x plus y squared over the square root of 1 plus x squared on C1 plus the integral, okay, 1 plus x squared over the C2. So we do each part separately for the C1. So for the integral x plus y squared, okay, I'm sorry, there is a ds for all of them. Differential of the arc length, differential of the arc length, and this is differential of the arc length. Okay, so for the C1, so this is going to be the case, you know, that you change it to the FTDT and then you integrate it. That's going to be for C1. You have to give us what is going to be the equation of the C1. So the C1 is a line from 1, 0 to 1 and 1/2. Different way to get this equation. R of t is going to be equal to, you see the x part is fixed, so it's going to be just 1, and you're going from 0 to 1t. So we can call it t, and then t is going to be between, okay, in order to get the 1, t must be 1, and in order to get the 1/2, t must be 1/2. Okay, so this is going to be your equation of the line. So the rest is just you just you know that you substitute over here and you get the r prime of t. Okay, so this is going to be the case. So r prime of t in this case, r prime of t is going to be what? It's just going to be 0 and 1, and 0 and 1. And then what you are going to do is you just go back and substitute. You say f of rt, if you like. So this is going to be the case. The norm of the r prime of t is simply 1 in this case. Okay, is going to be equal to the 1. And then you get your function. You see, you put the x equal to 1 and y equal to the t into the function, and you change the integral into the integral in terms of the t. Okay, 1 plus x squared ds would be changed in respect to the t going from 1 to 1/2. Then you substitute, your x is equal to 1 and your y is equal to t. So that gives you 1 plus t squared divided by the square root of 1 plus t squared. And this is it. R prime of t is equal to the 1 and then the dt. Okay, that's very low. Is a scalar value function, so we just need to multiply by the r prime of t. Okay, so this is it. So you have to integrate it to get this one. So what you can do is going to be you can break it into two parts to integrate it quickly over here. Okay, I just make sure that you get it. All right, so I got the that's x plus y squared radical 1 plus x squared, and then I get the, sorry, I should have to, I didn't bring the ds, okay, because I just directly substitute. So the ds is simply what? ds is 1 plus t squared. I missed that one, okay? So this is going to be 1. So the c1, I repeat it again, 1 plus t squared over radical 1 plus t squared. So the times it by radical 1 plus t squared dt. These two will cancel out. So you get integral from 1 to 1/2 of 1 plus t squared dt. And the result is going to be what? It's going to be t plus 1/3 of the t cube from 1 to, okay, this is it. It's going to be from 0 to, sorry, that's a 0. You have the solution, you can check it. 0 to 1, so if it's going to be 1 plus 1/3. Okay, so for the first part, I'm going to get what? I get to the 1 plus 1/3, which is going to be 4/3. Okay, so that give you the result of the first part, and then you go back and you check. Just give me a minute so I can check this. It's very hot in here. So this is going to be okay. So this is going to be the result. Okay, so I did it on the. I just have to double check this, make sure you get it right. So I got the. You have the solution 0 plus 1/2, 0 to 1/2, 1 plus t squared. Then what I'm missing somewhere. It's going to be, sorry, I missed something here. I made a made a mess over here. So I got the r prime, which is 0, 1. This norm is equal to 1. So I get to the function. So I got the function is going to be, I'm sorry, I missed something because x was equal to the 1. It just, I have to rewrite this one. You have it in your overview. I was confused because x is equal to 1. Okay, you have the solution where I have to rewrite and make sure you get it. Sorry about that one. You see, I missed it because RT was 1 and T. Sorry about that. You see, I change it again. You see, that's a C1. So your X was 1 and the Y was T. I missed it here. because R of t was 1 and t. X is 1. I didn't use the 1. Okay, and the R prime of t is simply 1 and 0. Okay, so I get the norm of R prime of t, which is equal to 1. So this is where I made a mistake. So this is the integral that I have. C1, call it the function, f of x and 1, and that's a ds. So I have to change it. It's going to be the C1. So the function is going to be 1 and t. This is where I made a mistake. Okay, it's going to be 1 and t. Okay, and the ds r prime is equal to 1, and the, okay, this is it, ds. So if you substitute your t going from 0 to 1/2, the function, remember, was x is 1, y is t. This is where I made a mistake, is 1 plus x squared, x is 1. So there is a radical 2 here that I missed. Okay, so this is going to be 0 to 1/2. And I have 1 over radical 2, 1 plus t squared dt. Okay, that was why I didn't see it. So this is going to be 0 to 1/2, 1 plus t squared dt. Now you integrate it, that gives you 1 over radical 2, and this is t plus 1/3 of the t cubed, going from 0 to 1/2. If you substitute the 1/2, so that 1 over radical 2, that's going to be 1/2 plus 1/3. Okay, 1/2 cube, which is going to be 1/8. Okay, and if you put the 0, we get nothing. So that would be, you can use your calculator, 1 over radical 2. That's a 1/2 plus 1 over 24. Okay, you think about it, 12 over 24. So that gives 1 over radical 2. So the top would be 13 over 24. And the final answer is 13 over 24 over radical 2. Okay, it's always the case for this type of integral. It's going to be a little bit messy, so be careful. Okay, so this is how we arrive at 13 over 24 radical 2 for the first part. Okay, it's a scalar values function. You just substitute to get the result. Okay, any question? That's a C1. So we have to repeat it for the C2 and we add them together. Okay, C2 is a part of the parabola. So C2 is you taking the point 1 and 1/2. Okay, that take it to the 0, 0. But you are going to do it along this curve, 1/2 of the x squared. So in this case, your x is, you can check your x to be equal to the t and the y to be y/2 of the t squared. But since you want to start with 1, so the best way to do it is that take the x to be equal to the, okay, x equal to the 1 minus t, and the y to be equal to the 1/2 times 1 minus t squared. So you got to be careful, because at the initial point you must get 1 and 1/2, and the terminal point we get that, okay, you get the 0, 0. So as you can see, if you start with the, if you start your t by 0, if you put t equal to 0, that give you 1. If you put t equal to 0, that give you 1/2. And if you put t equal to 1, and that give you 0, 0. Okay, so the way you put them together, you must double check to make sure that you know the initial points, everything is going to be consistent. Okay, so r of t in this case happen to be, r of t is going to be 1 minus t and 1/2 of 1 minus t all squared. This is going to be r of t, you differentiate it. So r prime of t is going to be equal to the -1. You differentiate this one, use the chain rule. 2 times 1/2 would be just 1. So that give you 1 minus t times the derivative of inside, which is a -1. So that's why your r prime of t is going to be equal to the, okay, it's going to be equal to the -1. And you apply this negative sign here, that make it into, okay, t minus minus 1. Okay, I differentiate it. So that's going to be 2, 1 minus t times a negative 1. So there is a kind of misprint in there in the solution that you have. Okay, so it's going to be t minus 1. So that would be your r prime of t. So you have to take the norm of the r prime of t. So the norm of the r prime of t is going to be equal to the square root of -1 squared, which is going to be 1. So it's going to be 1 plus t minus 1 all squared. You keep it and then you can square it if you need it. Okay. So the integral on this part, the function was f of x, y, ds. So you go to the function and you replace the x by 1 minus t, and the y by, this is going to be x is going to be 1 minus t. Okay, and your y is going to be 1/2 of 1 minus t squared. You can stay with the x and the y if you like. And the ds. So if you go back and substitute carefully, so the integral is going to be, your t is going to be between 0 and 1. Go to the function, substitute. So remember the function was x plus y squared. X is 1 minus t plus y squared. So y squared is going to be this one squared. So it's going to be t minus 1 or 1 minus t. You square it to the 4th, and the 2 squared would be 4. Okay, divided by a square root of 1 plus x squared is going to be 1 plus x squared. X is 1 minus t all squared. And then r prime of t, norm of the r prime. The norm of the r prime is going to be 1 plus t minus 1 all squared. That's the norm of the r prime times dt to get the integral. Okay. Again, you know, it's the function involved. Just wanted to see this type of a structure, but the one that you have are easier. So these two would cancel out. Okay, these two would cancel out, and you end up with an easier integral to handle. So this is going to be 0 to 1. Okay, 0 to 1, and you have 1 minus t. Okay, 1 minus t plus 1 minus t, everything to the 4th over 4, and simply dt. Okay, dt, and then you just integrate it. Okay, you can integrate it right away because this is going to be integral of 1 is going to be equal to the t. Okay, that gives you negative t squared over 2. You can use, use substitution type to get this one. You need u prime, you need a -1 if you like, so it's going to be negative. So that gives 1 minus t to the 5th over 5. And there is a 4 here, so 5 times 4. And then integral from 0 to 1. I just use the u substitution, 1 minus t as u prime is a -1. That's why I put negative here. Okay, so this is it. It's going to be t minus t squared over 2. And this is minus 1 minus t to the 5th over 20, going from 0 to 1. Okay, you substitute if you put the 1, so that gives just 1 minus 1/2, because this would be 0. If you put the 0, this 2 would be 0. So we get the negative, okay, we get the negative 1 over 20. Okay, so eventually this is going to be 1 plus 1/2 plus 1 over 20. 1 minus 1/2, that's 1. Okay, on the solution that I gave you, there is a different sign. Probably I missed the U prime here, but this is the correct one. Okay, this is going to be the correct one. And this is it. So this is going to be just 1/2 plus 1/20, which is going to be 20 and 11/20. 11/20, but positive. Okay, so this is the first part. And the second part, so eventually your integral is going to be the sum of the two. Sum of the two. On the first part, we get 13 over 24 radical 2, and plus the second part, we get 11/20. You can use your calculator if you like to confirm it, or to get this number down. Okay, so this is going to be, this is the only one that because the scalar values function, no theorems can be applied, so you can do it. You should do it straightforward. Okay, so that's first one. Any question? So just those points, just have to go through this. And that's why I want to explain it. And there was a sign here that I missed. Okay, so that's going to be number one. We give you one on the final. The second one is they ask for the work. We just want to make sure you remember that the work is just okay. When talk about the work, I just want to make sure you get the same one here. Yes. When you talk about the work, it's just the line integral. So we are going to give you one. We want to make sure you know this. Okay, number two. So we just change this, but it's going to be straightforward. So we'd like to find the work. So that's the idea, that you have to know that the work is integral of f dot dr, the line integral. Okay, find the work done by the force, done by the force. The force would be given to you as a vector field. So in this case, the vector field is this one. It's a y minus x squared, comma z minus y squared, and the x minus z squared. Okay, along the curve, over the path or the curve, over the curve r of t, which is equal to the t squared and the t cubed. But you want to do it from from the point 0, 0, 0 to the point 1, 1, 1. Okay, straightforward, but which was one section that we considered. So you must know that the work is equal to the line integral of the f dot dr over the c. That's the definition of the work. So this is going to be changed to it's going to be f of r of t. Okay, r of t dot r prime of t, then the dt. The dt, whatever t you have. In this case, t is going to be between 0 and 1. Okay, 0 and 1, you see, the x is t, so 0, 1. If you just substitute, you see it. Okay, any questions? So you must know this formula for the work. So just easy to find out. So this is it. You start with the RT, you get the R prime of t. So this is it. I want to find the f of R of t. So it's going to be f of the points are t, substitute t squared and the t cubed. You do this one into your function. Okay, to get f of R of t as a vector. So it's going to be equal to the y minus y is t squared, y minus x squared, which is going to be t squared minus t squared. Okay, that is going to be the first part. Then z minus y squared, your z is t cubed, minus y squared is going to be t squared squared, which is going to be t to the fourth. Okay, then x, your x is equal to t, x minus z squared, Okay, and the z is t cubed. It's going to be t to the 6, t to the 6. Okay, you can simplify this too. So f of r of t is going to be simply 0, t cubed minus t to the 4th, and the t minus t to the 6. Okay, so this is going to be your function. So dot with the r prime of t, you get r prime of t. R prime of t is going to be equal to r prime. You get a 1, 2t, and 3t squared. So get the dot product, then integrate it. Okay, get the dot product, f of r of t dot r prime of t is going to be equal to, you multiply these together. Okay, it's going to be 0 times 1, and that would be 2t times t cubed minus t to the 4th plus 3t squared times t minus t to the 6. Okay, simplify it, then put it inside the integral and then do that. So it's equal to, the first part's going to be 0, it will be out, so you multiply it. So that gives you t to the 4th minus 2t to the 5th. And this would be plus 3t cubed minus 3t to the 8th. That's it, nothing to simplify. So the work is going to be integral from 0 to 1 of 2t to the 4th minus 2t to the 5th plus 3t cubed minus 3t to the 8th all dt. Okay, you integrate it and then you substitute, easy to integrate. It's going to be what? It's going to be 2t to the 5th over 5. Okay, minus t to the 6 over 6. Then 3t to the 4th over 4 minus 3t to the 9 over 9 to be evaluated from 0 to 1. Okay, if you put the 0, you get nothing. And if you put the 1, you are going to have the following. So it's going to be 2/5 minus 2/6 at 3/4 and okay, 3/9 if you like. So this is going to be the case. You can simplify it and just find the common denominator to get the final answer. So the final answer would be 29 over 60. Okay, you can simplify this one. That give you 1/3, and that give you 1/3 again. Okay, this two would be negative 2/3, and it's easily seen really that you get that number. It's a 2/5, so that gives you negative 2/3 and the plus 3/4. So the common denominator would be 60. So over here, that gives you 24. And over here, that gives you 20/40. And over here, you get a 15/45. So as you can see, this gives you 529 over 60, the final answer. Okay, so one question on the work would be given to you on this test, and it's going to be straightforward because the vector field and that dot product is easy to handle. Okay, determining the limit of integrations. You see, this is the curve that you have. So this is your curve. Okay, this is initial, and this is the end. So we just compare them together. You see, for the initial, you just check to see for what value of t you get 0, 0, 0. You say t equal to 0. So that gives you the initial points. And for the end point, you see t equal to 1. So t equal to 0, that gives you 0, 0, 0 initial point. T equal to the 1, that gives you 1, 1, 1. Okay, so at these two values, you just compare it and you get those numbers. Okay, sometimes it takes a little bit more time, of course, but it can be done. Okay, so don't miss it. This is, for example, one of those questions that you have to do first. When you read the questions, you see the work, because it's very straightforward integral. They cannot do anything else to it. So it can be done quickly. So do this one first. Okay, so that's question on work. So that was the line integral, that's work. Now, the rest of the question on this is going to be regarding the properties of that line integral that we have. We have the independent of the paths. So this number 3 is a special problem, you see. And you know that if the force is going to be conservative, then their integral would be independent of the paths. But there is always the condition. The condition is that your force, you know that you have to have a continuous continuous partial derivatives. And this example is around in calculus for some other purposes. You see, they give you this. Let f of xy is going to be equal to what? Is equal to negative y times I plus x times j. Okay, and this is going to be x squared plus y squared. This is going to be a force in plane. So what we'd like to do is we would like to see that integral of this function, okay, the line integral, is not independent of the paths. Is not, they suggest to compute this one in 2 directions and give us the different answer. So they ask you to compute. It's very kind of very rare example. Just this is for your understanding of the theorem. We wanted to compute this integral along 2 different paths. Okay, 2 different paths, and ensure that they are different. Okay, where C1 and C2, both of them are going to be upper part of a unit circle. So these are the upper and lower. Yes, one of the upper and lower. Okay, lower halves or the semicircle. Halves of the circle. Okay, of the circle x squared plus y squared equal to 1. But they give you the initial points to be from 1 and 0. Okay, from 1, 0 to negative 1 and 0. Okay, they ask you to find it, then conclude that the integral is not independent of the paths. Okay, is not independent of a path. Now, on the other version, this a kind of integral would be given to you, and they ask you to prove it's independent of the paths. If you want to prove that it's independent of the paths, so this force must be conservative. So if this is going to be conservative, you know that it's going to be conservative. It's a function of, it's going to be on the plane. So you break it in 2 parts, you get the P and the Q part. Remember, round P, round Y must be equal to the, you see, look at this one. So if you get this function, if you break it into the component part, so it's going to be negative. So it's a negative y over x squared plus y squared. You see, times I plus, and the other part is going to be x over x squared plus y squared times j. You see, this is going to be your p function, if you like, and this is going to be your q function in a sense of that we did for the kind of checking the conservative function. It's very interesting one. If you check, it satisfies the condition that you see, if you take the derivative of this one respect to the y, if you take the derivative of this one respect to the y, is going to be equal to the taking the derivative of this one respect to the x. Okay, so if you go with the usual one, so you can check This is not part of the solution of this problem, just for your information. You can check that the round P round Y is equal to round Q round X. Okay, and some people, as soon as they check this one, they say, oh, so this must be conservative and this must be independent of the paths. But there is only one difficulty for this one. The condition is, if you look at this function, you see this function, look at these. If you want to check the continuity, because when you differentiated this x squared plus y squared with v2, so this denominator would be 0, this denominator would be 0 at 0, 0. So these functions p and the q are not continuous at 0, 0. So when they are not going to be continuous at 0, 0, and you have the unit circle over here, so you don't have all the conditions for your function to be conservative, or for your integral to be independent of the paths. Okay, so that's the purpose of this problem. But the way I write it down for you, just to evaluate it, that would be more fun, to evaluate it, to show that this is not going to be independent. So you may see this problem. This is very popular example in calculus 3. So you may see it in different formats. But the one that we would like to do, we'd like to just to evaluate it. Okay. So there you are. Go with the C1 and the C2 and just find it. So what is going to be C1? You have the unit circle. Okay, so you have x squared plus y squared, okay, equal to 1. You know that the equation for this is going to be r of t equal to the polar coordinates. Okay, components give you what? That give you, the radius is 1. So this is going to be cosine t. Okay, and this is going to be sine t. Cosine t, sine t, of course, for the full circle. So the full circle is going to be 0 and 2 pi. Okay, that's a full circle that you have. But the way you've been asked to evaluate this integral is for the semicircle. Okay, that's going to be a -1, and this is going to be a +1, and this is up and down. So this is what you have. Okay, so your C1 is the top one along the C1. So this is going to be the C1, the top. Okay, this is going to be the C1. Okay, and the bottom one is going to be the C2. So this is going to be the C2. Okay, lower and the upper. So you have to get this equation and find the integral separately. So I go with the C1 first. So the C1. So the equation is going to be almost the same. So I have the r of t, which is going to be what? R of t is going to be cosine of t and the sine of t. But what is going to be the value of the c that you're going to pick? So the C1 is from 1, 0 to -1, 0. You see? 1, 0. This is 1, 0. Okay, 1, 0 to the what? To the -1, 1 and 0. So this is the direction that you're going to have. Okay, so we know that it's going to be semicircular. So your t is going to be between 0 and pi. So you got to be careful. Okay, this is it, to make sure you get these points. So if you put the 0, you must get the initial point here. Okay, you must get your initial point here. T equal to the 0, cosine of 0 is 1. So that give you 1, 0. Then you want to end up with the what? End up with the -1 and 0. So to get the -1 and 0s, you must be between 0 and pi. Okay, if you put t equal to the 0, that give you the first point, 1, 0. If you put t equal to the pi, that give you the other part. So this is the way you're going to pick the t. Okay, so let's find out what's going to be the integral for this part. Okay, so what is the integral of the red part? I stay with the red. So we would like to find the f dot dr this time over the C1. So you go to your function. Remember, you substitute directly because, okay, sorry, we need the r prime. Let's do the r prime as well before going to the integral. You know, the r prime of t would be what? Would be negative sine of t and the cosine of t, and the norm of the r prime of t, it's a unit circle, so the norm is going to be 1. So we are not going to worry about it. So that gives you, the sine square of the t plus cosine square of the t. So this would be radical 1, we go to the 1. So this is going to be the case. So go back, substitute as we did it for the other one, and get this dot product to get that result. Okay, just double check that equation that we are dealing with. Okay, so this is it. Go back, substitute in the function that we have. Okay, you can go with the p dx dy if you like, or just get these numbers done. A little bit of algebra involved, but it's not going to be difficult. Remember, this is going to be your function, and you have to substitute first, then get the dot product. Okay, it takes time, it's bad, it's fine, we can do it. So let's work on this one first. So this is it. We have to find f of r of t, which is going to be f of r is cosine of t. Okay, sine of t. Go back, substitute into your function. Okay, this is going to be your function with the component that we're going to have. Okay, so the first part is going to be, this is it. So it's going to be equal to, we have the negative y is what? Y is sine. So it's going to be negative sine of t. Then x squared plus y squared would be just 1. Okay, cosine squared of t plus sine squared of t. So that would be 1. And the second part is x. So the x would be just cosine of t. Same thing here. So in fact, f of rt, you end up with the what? We end up with a negative sine t cosine t. Okay, that's going to be f of rt. Then you are going to get the dot product with the r prime of t, and then you integrate it. Okay, I'm just doing the work. The integral is going to be f of rt, r prime of t dt. Okay, so this is it. The second one is similar, so we do the first one and we get the second one right away. So this is it. You have to find f of rt dot r prime of t. Okay, so it's equal to, so f of rt is simply negative sine t cosine t dot r prime. Your r prime is cosine sine. Okay, if you get the dot product, you multiply them together, that gives you negative sine t cosine t. Okay, and this is going to be a positive what? R prime of t, did I miss anything? Sorry, r prime of t is a negative sine t cosine t. Negative sine t cosine t for the r prime of t. And, oh, both of them are the same. Negative sine t, I made a mistake here. It's a negative sine t cosine t, both of them are the same. Okay, so simply what you get, it's equal to 2 or equal to 1. So what you are going to get over here is going to be negative positive sine square of the t plus cosine square of the t. Okay, is it going to be equal to 1, and you integrate it easily. So the integral of f dot dr over the c1 would be changed to simply 1, 0 to 1, 0 to pi, 1 dt. So it's going to be equal to the pi. Okay, it's going to be t from 0 to pi. So this integral would be pi. Okay, the integral of the C1 is equal to the pi. And similarly, the second part is going to be, any question on this one? C2 is very similar, but you got to be careful. C2 is a semicircle again, so this part is the same. R of t is the same as cosine of t sine of t. But you got to be careful about when you want to take, okay, to pick these values to get it. Remember the C2, look at the C2. C2 is going to be a point from, okay, from 1, 0 to negative 1 and 0. Look at this one. That's a C2. That's a C2. You want to go from 1, 0, 1, 0 to the, okay, to the negative 1 and 0. So in order to get the initial part, which is going to be 1 and 0, you have to, and this is your equation again, it's your equation. So if you put to get the 1, so you need the cosine of 2 pi. The cosine of 2 pi is going to be equal to 1. And in order to get to the negative 1, you get the cosine of the 2 pi and the pi. So you must go from, this is a t must be between 2 pi and the pi. Okay, but the direction of the integral is going to be different. You see, look at this one. It's going to be f dot dr on the C2 is going to be integral from 2 pi to pi. Okay, f of rt and dot r prime of t dt. Everything would be the same. You get the one that you got over there. So it's going to be 2 pi to pi. Okay, 1 dt. You know that integral of the 2 pi to pi. So that gives you t. T is going to be from 2 pi to pi. So it's going to be pi minus 2 pi. So the result would be negative pi. So they are different. Most of the people, they miss this part. They write the second integral as pi to 2 pi, which is not correct, because that won't give you the direction that you're going to have. Okay, so if one part is pi, the other one negative pi, so this means f dot dr over the C1 is not equal to the f dot dr over C2, and that's what. Okay, I just wanted to see this example because most of the people, I gave this one once on the test, but this is just for your information. The one that you're going to have, the force is, you are going to be asked to prove that the force is conservative, and that will, it's like the number 4. Okay, any question? So just to observe this one, this is just one question, one type of example. Of course, you are not going to see it on the test, but that gives you a better idea of this concept. That was the purpose of this problem. Okay, but we give you the next one on the final. Number 4, be prepared for it. Number 4, we are going to break it in 2 parts exactly as is over here. And we give you the function. We ask you to prove this integral is independent of the paths. Of course, we force you because when it's going to be independent of the paths, the integral over any path is going to be possible. So you'll be able to answer the question. Okay. So number 4, not number 3, number 4. Suppose. So this would be your question of the independent part that I talk about it. So we have the force. The force is 2x. Again, it's a straightforward function. This one got a little bit more involved, but it's not bad to practice. This is the force. Okay, is a given vector field. So what we want to do is we wanted to prove it's conservative. Okay, all you have to prove it eventually, you see. Show that the field is conservative. The field is, okay, conservative. Instead of this, you may be asked, you see, is equivalent. You may be asked this one. Show that, okay, show that the integral of f dot dr over c is independent of paths. So both of them are the same. So in this quiz, we give you show that f is conservative. You know that if it's going to be conservative, that's independent of the path. So if this is not given to you, they just ask you to prove this one. It's the same thing. You have to prove that this is going to be conservative. Okay. Then they say, oh, okay. Now part B. Part B, you want to use it or you have to use it. They ask you to evaluate the integral. Okay, evaluate the integral of, okay, f dot dr over c. Okay, and they know in this case they write it down as in the form of this is the way they give you, which is the same thing, 2x dx minus y squared dy minus 4 over 1 plus z squared dz. Okay, they ask for this integral, but look at this. When c is any curve, not a specific one, any curve that connect, okay, these points between, any curve between the points a equal to the 0, 0, 0 and the point b equal to, okay, b equal to the 3, 3, 1. You see, this is going to be a question on the independent of the path questions. Okay, so we know that this is a great theorem and we already talked about it, so you should be able to handle it nicely for us. So you prove that it's conservative. You know that you prove it's conservative if you can find a conservative force for it. Okay, so since you need that potential force, so you will go for it. If you can find that, automatically you proved also that it is going to be conservative, okay, because you need it for the second part. So as soon as you prove it, or you can say that this is independent of paths. Since it's independent of paths, I just get a straight line that connected, going to be connected A to the B. So we just need the endpoints. Okay, we get the potential function evaluated at this point, and then we're done. Okay, so that's going to be a typical question that will take us through these two great theorems that we have. So the first part, this is what you have to do for us. So you check to see if you can find a function would satisfy this condition. Okay, so if you can find this function automatically, this means this is also conservative. Okay, you don't have to prove it. You know that you have to prove the k is equal to the 0, but this is another way to do it. So get this function. Okay, get this function. So what we need for the function, so it's going to be f sub x, f sub y, and f sub z. This must be equal to what? Equal to the 2x negative y squared and the 4 over 1 plus z squared. Okay, so just get the system of the equation that we have. So this is the way we are going to check those questions. So it's going to be a 2x. Okay, it's going to be, this is going to be negative y squared, and f sub z is equal to 4 over 1 plus z squared. Okay, you know that these are equation number 1, 2, 3. So what we have to do is you start integrating the respect to the one of them. So that would be easier. So integrate respect to the x, so f of x, y, z is going to be equal to, if you integrate respect to the x, it's going to be integral of 2x dx okay, is going to be x squared, but you may have a constant. Your constant can be a function of y and z. So this is going to be the first part. Then you know that you drop it into number 2 to see if there is any y in it. So we find f sub y. F sub y is going to be equal to, this is simply 0, and this would be, okay, this is going to be equal to the 0, and this is going to be around the g, around the y. But we have it from number 2, okay, that this is a negative y squared. So you compare them together. If you compare them together, you arrive at the fact that the round g, round y must be equal to the negative y squared. Okay, so you take the, you get the integral in respect to the y. So your g of y and z is going to be equal to the integral of a negative y squared dy plus a constant. This constant can be a function of z. So this is going to be negative what? And negative 1/3 of the y cubed plus the function of z. So if you put it over there, so far your function f is going to be equal to, okay, so your f function is going to be equal to the x squared, is going to be x squared minus, if you like, y cubed over 3 plus the h of z. But you have to check to see if there is any z in it. So to get the z, we are going to find the f sub z. So the f sub z, everything would be 0. So we get only a h prime of z. But we have from equation number 3 that f sub z is equal to what? Is equal to the 4 over 1 plus z squared. You compare them together, h prime of z would be 4 over 1 plus z squared. You integrate, you know that it's a tan inverse. So if you integrate it, so h of z is going to be 4 tangent inverse of z. So you put them together and you are going to have your function to get this number done. Okay. Any question? So I'm going to put them together to get the function, and then it's going to be automatic is conservative because you get the potential one. Okay, since you want to do the, okay, the next part. So we know that this is, it's positive. Okay, so I'm going to put them together to get the f. So what is going to be your potential function now? Okay, so there you are. So the potential function that we get is f of x, y, z is going to be, and this is going to be the function x squared minus y cubed over 3, okay, minus 4 tangent inverse of z. You can add the constant c, but we are interested in only one function. Okay, so that's going to be the one. So this shows that the f is a conservative, okay, it's going to be a conservative vector field, and that's important part. And the integral f dot dr over c is independent of the paths. Independent of paths. Okay, since it's dependent of the paths, so therefore, if you like, therefore we go. So that was the part one. Therefore, for part B, since independent of the paths, so we get any path we like. So this is it. F dot dr over c is going to be what? Remember, is going to be, you know it. You can write it down if you like. It's going to be, we have the potential function. So it's going to be f of r of b minus f of r of a. It's going to be evaluation of this function at the endpoints. So since it's free, we just pick a segment. If you pick the segment, this initial point is going to be just the initial points that you have. So you have the A is equal to, remember from what? A is equal to the 0, 0. That's your initial points. Okay, you can call this one R of 0. Okay, R of 0 if you like. And the other one is 3, 3, 3. You don't need them. You may call them R of 3, which is equal to the, okay, which is, you just substitute together. So basically, the integral f dot dr or c is going to be f of, that's it, f of 0, 0, 0. I'm sorry, initial terminal point, f of 3, 3, 3. F of 3, 3, 3, the terminal point, okay, minus f of 0, 0, 0. Go to the function, substitute to get these two numbers. Okay, there you are. F of 0, 0, 0 is going to be 0. Okay, 0 minus 4 tan inverse of 0. You want to find the function whose tangent is 0. You know that that function is 0. So this is going to be, everything would be 0. Then you find the other one, f of 3, 3, 3. So go to the function, substitute. So that gives you 3 squared minus 3 cubed over 3 minus 4 tan inverse of 3. Okay, so that gives you what? 27 over 3 would be 9. 3 squared would be 9. So these two would cancel out. So we get the negative 4 tan inverse of 3. So, you know, you can use your calculator if you like to have it, or otherwise you just write it down as is. So the integral of f dot dr over c is going to be equal to, that's it, equal to the negative 4 tan inverse of 3. And then you're done. Okay, very nice problem, because we check a couple of theorems. We check, okay, so we check 3 theorems in this problem. You know, we check the fact that, you know, it's conservative independent of the paths, and then we check that if the force is conservative, we can use fundamental theorem of calculus, fundamental for line integrals to find this, okay, to find this integral. Okay, so be ready for it. So now you know it. As soon as you see it on the final, you go for it. This is one of those problems that you have to do first, okay, because it's straightforward, nothing, you know, nothing unusual about it. So you'll be able to do it right away. You'll be able to do it. Okay, so that was question number 4, independent of the paths. Number 5 is easy. It's just evaluation. Don't expect it for the final. Okay, I can do it quickly, just give you the answer, but you won't see it on this type of problems, because you are going to find the care for us on that care, but not officially. Okay, number 5, just to complete this, you have a vector field, and then you want to find the curl and the divergence. That's it. So just to have the solution in order, suppose this is it, f of x, y, z. This is going to be the one I write down in, you know, in vector form. So it's e to the negative x sine of y. Okay, and you have e to the negative y sine of z, and you have e to the negative z sine of x. Okay, this is the function e to the x sine y, e to the negative y sine z, and e to the negative c sine. They ask for the curl, you know, this is it, they find. They ask you to find the curl of f and the divergence, okay? And divisions. So that's a straightforward problem, and just the definition only, okay? We need the definition of both of them on the test. Just one, give you this one, make sure to remember to bring the formula for both of them. Okay, but otherwise it's nothing special about this problem. So we go with the curve. I like the matrix form, so you can do the formula if you have it. So this is going to be the metric form, and this would be I, J, K, differentiating respect to the X, respect to the Y, respect to the Z, okay? And the function. And the component of the function is a e to the negative X sine Y. Okay, e to the negative Y sine Z, and the e to the negative Z sine X. That's it. Just operate it to get it. So this is going to be equal to the I times, eliminate. So you have to find the derivative respect to the Y, which is not possible, it's 0, minus derivative respect to the Z. Derivative of sine Z is cosine Z. So it's going to be e to the negative Y cosine Z. That's the first part. Okay, minus J times, and J times. So derivative respect to the X, that give e to the negative Z cosine of X minus derivative respect to the Z. There is no Z here, 0. Okay, plus the last one, K times. Eliminate the first row, the last column, and derivative respect to the X as 0, minus derivative respect to the Y, it's just e to the negative X cosine of Y. Okay, so this is it. So that gives a negative e to the negative Y cosine of Z times I. And this would be, okay, this is going to be plus, if you like, a negative e to the negative Z cosine X times J. And then the K is a negative e to the negative X cosine of Y times K. That's the curve. Okay, that's a curve. So the divergence is easy case. Divergence is a scalar function. Any question? Just a straightforward to warm up if you like. So division, make sure you know the formula. So is going to be just round P, the first component, round X, round Q, round Y, round R, round Z. The component of the function, okay, so it's going to be equal to, if you want to see the function that I'm going to use, is a round X of this function plus round Y of this function, and the round Z of this function, e to the negative Z sine X. Okay, so differentiate respect to the X, that gives just negative e to the negative X sine Y. Done. Differentiate respect to the Y, so that gives negative e to the negative Y sine Z. Differentiate respect to the Z, that gives negative e to the negative Z, okay, sine X. So that would be the divergence. Okay, so don't expect it to be repeated on the final, but you need the formula for both of them. You need this one, you may have to use it. Okay, any question? Now the big one, of course, is the Green's theorem. We give you one on the test, on the final. So the Green's, you know that you are going to have a function with the given is it's going to be a function, it's going to be a vector field on the plane. So it's a function of two variables, okay, vector valued function, two variables, and then there's the domain, and this domain would have a boundary. You want to find the line integral on the boundary of that, okay, and then you can switch it into double integral. So that would be question number 6, Green's theorem. One of those questions is Green's theorem. It's not difficult. Okay, to get to read, be careful. The way you're going to pick that C is important. So the question is use Green's theorem. That's it. No other method, remember. Use Green's theorem. Use Green's theorem to evaluate. To evaluate what? Integral. That's it. A square root of 1 plus x is that cubed. 1 plus x cubed dx plus 2xy dy. You know that function must be in the form of the p dx q. Okay, well, C, where C is, okay, in this case is a triangle. Is the triangle, okay, it's going to be a triangle with the following vertices. With the vertices are the origin, okay, origin 1, 0, and 1 and 3. Again, the Green's theorem is one of those questions that you have to do first because it's going to be very easy to evaluate, okay? So that the region that you create is important, okay? Sometimes it may be type 1, type 2. So these are going to be the purpose. You have to sketch the graph to see which type is it. Then because you change this one into a double integral, okay? So basically this is going to be your Green's theorem, okay? So you know that this is your Green's theorem, p dx plus q dy over the C is going to be a double integral. So C is going to be a boundary of a domain that you put over here. Okay, and they get the round Q, round Y minus round P, round X, then the dA. Depends on what is going to be the D, okay, the domain that you're going to have. So D in this case is going to be the point inside and on the triangle, and the C is going to be the boundary of the triangle. You see, this is going to be the case that you have. So you have 0, 0, this is going to be 0, 0. Then you go to the 1, 0, this is going to be 1, 0. Then you go to the 1 and 3. So this is going to be 3. So this is going to be 1 and 3. So your triangle is this one. You see, this is going to be your triangle. So this is the domain G, domain D. Okay, as you can see, it can consider as a type 1 or type 2. And the C is this one. This is going to be C. No, it must be a closed curve. It's closed curve because you start with the point and you come back to the original one. So everything is satisfied to get these numbers. So the only thing that you have to do for us is, so we got the C. Okay, you have to check the domain when you want to integrate it. So get the P. So your P is going to be radical 1 plus x cubed. So from here, you have to find the integral respect to the y, which is 0, because there is no y on it. So your q is going to be 2xy. So you have to find the round q round x, which give you 2y. So if you go and substitute your integral, p dx plus q dy on the given curve would be now the double integral on this domain, which is a triangle, and the difference of the 2y minus 0, the dA. So that gives you the double integral of the 2y dA on a triangle. So just check to see what's going to be the limit of integrations over here. So we got this triangle, so you can go with fix the x 0 to 1 and go up and down. So take it as a type 1. You may get type 1 or 2. See type 1, up, down, up, down. So the down is y equal to 0. Up is going to be aligned through the origin, but the slope is 3. So this line, the equation of this line is y equal to the 3x. Okay, so your x is between 0 and 1. Your y is between 0 and 3x. Okay, so it depends what type of domain you have. You may have a domain connected or bounded by two curves, but it's not going to be a big deal. Okay, so now you know that your integral, you are going to integrate in what? So the double integral, your x is fixed from 0 to 1. Okay, and the y is between 0 and 3x. And the function is 2y. 2y integrate respect to the y first, then the x. And again, the integral is very easy when you put them together. Okay, so integral respect to the y would be just 0 to 1. 2y would be 2y squared over 2, which is y squared. So that gives y squared, but y going from 0 to 3x. And when you're done, the dx. If you substitute the 3x, that gives you 9x squared. So that would be integral from 0 to 1, 9x squared dx. So that gives you 9x cubed over 3 from 0 to 1. It's going to be 9/3, which is equal to 3. So that integral is easily seen. That's going to be equal to 3. Otherwise, you can't do it. You see that radical. If you want to do it, quickly or just directly, then evaluation of that integral would be difficult to get the radical 1 plus x cubed. But the application of the Green's theorem give you nicely the job. So this was your quiz. Just give you an idea or how going to pick them. So from this quiz, as you can see, and this is it, Green's theorem. I repeat it again. That was the Green's theorem. Nothing to do with that. Number 4, very important problem. I give you an integral. You prove it's independent of the paths. That would enable you to find the integral at over any path. So just the integral, when you find the potential function, it's just the evaluation of the potential function at the endpoints. So that is going to be our second one. This is just for your idea. It's not going to be important. I give you, it's a very counterexample for these theorems. Then, of course, number 2, work. You must know it's a straightforward problem, really. You should do it right away. And so a vector field would be given to you and the curve. So work is integral of f dot dr. And number 1 is finding the line integral directly. That was a little bit messy because of the nature of the function, but the one that we have are going to be nicer to get this number 2. Okay, so we are going to have a break and come back. I'd give you some examples on the surface integral, because the surface integral is challenging, especially the surface integral on the vector field and the verification of the Stokes theorem. So that would be 2 more questions, and these 2 questions takes times. So you better arrange everything else and then come back and do this last 2. Okay, so it's 12:14, 15 minutes. I come back and I do those. You have a 3 or 4. Let's see how you have the solution, but I want to explain it because there are a couple of points that we have to explain. Okay, see you then. So you have the solution of the review all together and the solution of the quiz, and you study all this. Okay, so we need to get a couple of examples, or at least one, on the surface integral. And that would be your next challenge, and it takes time a little bit to find the surface integral. Okay, so when you do this surface integral, especially for the scalar function, you end up with the kind of integration substitution type that you have one or two. I mean, in calculus one, or sometimes with calculus two. So I'm going to do one of them for you, is especially number 25. So it's a surface integral. We give you one of them. Is going to be evaluating surface integral. Surface integral is going to be surface integral of the scalar valued function, okay, of a scalar valued function. Okay, because it's going to be one with the vector field. The vector field one is the one that's going to be connected to the Stokes theorem. Scalar valued is just a straightforward one. So you have it in 2025. So if you want to do the scalar field one, this is going to be the formula that we're going to use. You see if you want to find the double integral or the surface. So your function is going to be f of x comma y. It's a scalar valued function, okay? And the differential of the surface. So what we do is you are going to change it into, okay, we're going to change it into, is going to be a double integral on the domain that you're going to determine. So your function is going to be a function of, okay, and this is going to be f of, okay, so the function is going to be a scalar value, so it can be f of x, y, and z if you like. So then what you do is going to be f, x, y, replace the z by the equation of the, okay, parametric equation of your curve, of your surface, and that give you 1 plus gx squared plus gy squared. Then this is going to be the dx dy. You know that the general formula that you have for this part, this would be like, so this is going to be for the surface, for the scalar valued. If it's going to be vector field, you know that this would be just the normal. Okay, this is going to be a normal vector in general, and this, okay, and the equation of the z, if you like, in this case, z is equal to the g of x and y. So parametric equation of your surface would be given to z equal to the g of x, y. Then you have to evaluate the function at over the surface. And this is going to be the vector. This is the norm of the r prime of t that we do it. Okay. So, you know, if you like, the other version is the same thing. It's instead of, you see, this is going to be the case. So we get the d. This is f of r of, remember, r of a uv or xy. In the case that you got over here, okay, is x comma y, and this is simply norm of the normal vector, norm of the n of the, okay, is going to be n of the normal vector times the dx dy. I'm going to do it. You will see it. We're going to do it. Okay, in 25, what you want to do is, this is 25. You want to find this integral when S is the upper part of the hemisphere. Okay, so the parametric equation of your curve is going to be a kind of the type that we talk about it here. Okay, so you want to evaluate. You want to evaluate this x squared y squared on the surface S. Okay, surface S, when S is what? Is z equal to 1 minus x squared minus y squared. Okay, that's going to be your C. So what we are going to do for this, since Z is already given to you, so this is the way we do it. So this is going to be Z equal to the G of X and Y, which is radical 1 minus x squared minus y squared. And we are going to find the G sub X, remember, to get your normal. So in this case, G sub X is going to be, you write this one as 1 minus x squared minus y squared to the 1/2. Okay, to get this one. So G sub X is going to be, there's going to be negative X. We did it before. Negative X 1 minus x squared minus y squared, and the G sub Y is going to be, it's a negative y over radical 1 minus x squared minus y squared. So you take that square root, so we get the TS, if you like, is going to be 1 plus gx squared plus gy squared. So in this case, when you substitute, okay, when you substitute inside, it's going to be 1 plus, you get the x squared over 1 minus x squared minus y squared plus y squared over 1 minus x squared minus y squared. And if you find the common denominator, the result would be easy. So the common denominator would be 1 minus x squared minus y squared. The top is going to be 1 minus x squared minus y squared plus x squared and the plus y squared. So everything would be canceled out. So eventually you arrive at 1 over a square root of 1 minus x squared minus y squared. So that would be this radical part that you have. So you go to the function. So this is going to be your double integral x squared y squared ds over the s is going to be equal to. So you substitute, it's going to be on the domain D. The function is in terms of the x and the y would be stay the same. So that give you x squared y squared. That radical part is 1 over 1 minus x squared minus y squared. And the rest are going to be just, we call it dA. Then we decide what are going to do about this one. Okay, so eventually we have to find this integral, a double integral of x squared y squared over the 1 minus x squared minus y squared over the dA and the d. For the d, you have to get the projection of this surface in 2-dimensional. What is going to be your d? You see, you have the hemisphere with the radius of 1. So if you drop it down into the xy coordinate, that gives you a unit circle. So I have to go to the next page to continue find this integral. So the way you are going to identify it is going to be, so if you like, projection onto xy plane is going to be t, is going to be a collection of points xy such that, so it's going to be x squared plus y squared, okay, is going to be less than or equal to 1. Remember the S was a hemisphere, So the projection is going to be just a circle. So since it's a circle, you have to change everything to the polar coordinate. So we change it to the polar coordinate of the r to be between 0 and 1, and the data to be between 0 and 2 pi. And then we are going to take care of that, okay, that integral. So in this case, your x, you change the x into the polar coordinate, cosine of the data, y equal to the r sine of the data, and from now on is going to be just a double integral. You see, this is it. You have the x squared, y squared divided by 1 minus, you can factor out, that give you x squared plus y squared. And that was the dA on your domain. You change it to the polar coordinate, is going to be equal to your r going from 0 to 1, your data going from 0 to 2 pi. You change the x and the y. So that would be r cosine of the data all squared, r sine of the data all squared. And the bottom one would be 1 minus r squared, okay? And extra r for the polar coordinates and the dr and the d data. Okay, all of them can be done easily. So you get r squared, and the r squared r to the 4 times r would be r to the 5th. So it's going to be 0 to 2 pi, integral 0 to 1. Okay, so cosine square, sine square, I'm going to get these separated. So that gave me r to the 5th. Okay, that gave me 1 minus r squared. The leftover cosine square of the data, sine square of the data, and then, okay, the dr and the d data. So the one that I want to emphasize is this integral. You see, you have to integrate this one respect to the r first. So sometimes it's happened. The one on the test is easy. You are not going to have this type of argument, but just to know it, how we're going to handle it. You see this type of integral from calculus 1. So we usually go with the u substitution, okay? But then you have to modify your result. It's going to be r to the 5th times 1 minus r squared, okay, to the negative 1/2 dr. So we hope to be able to do it by u substitution. If you take the u to be 1 minus r squared, then the du would be negative 2r dr. And when you find the dr, so that gives you the du over negative 2r. So when you substitute, you expect this r to the 5th to be canceled out. But this is not going to be the case. If you see, if you substitute over here, if you put this negative 2r, I do it so that you know that what is going to be the difficulty. You see, this is going to be 0 to 1. You have the r to the 5th. This would be u to the negative 1/2. Okay, and the dr would be the dv over negative 2r. You see, you simplify this, there is going to be a leftover of r to the 4th for these problems. You know that you can do the u substitution if the function is going to be totally depends on u or r. So the difficulty is going to be this one. You end up with the 0 to 1. Okay, it's a kind of negative 1/2 r to the 4th u to the negative 1/2 du. You can't do it because you still got an r here. So what we do, as we did it in a couple of problems in calculus 1, so what you do, you go back, you go back and you find the r in terms of the u. Then you come back and you substitute. So going back means you take the u to be equal to the 1 minus r squared. So you find the r squared. So r squared would be 1 minus u. So r to the 4th would be 1 minus u all squared. So you substitute here for r to the 4th, 1 minus u squared, then you'll be able to do it. There was one problem in calculus 1 that we usually do this method. This is it. And there are two problems in calculus 1. This is one of them, and this is the other one. You do exactly the same method. This is a problem in calculus 1. Of course, you can do this by integration by parts. It takes so much time to do it. Okay, so that's the idea. Sometimes it's happened, but the one on the test, you are not going to have it. So you have to substitute here now for r to the fourth, 1 minus u squared, then that keep you going. Okay, so I'm going to go to the next page and do it for you. So it's happened in two of those problems on the final review. So this is it. We have the 0, 1, negative 1/2. I repeat it. We have the r to the fourth, u to the negative half, du. So this is it. I pull out the negative 1/2, negative 1/2, integral from 0 to 1, and I replace this by, remember, this by what? By 1 minus u all squared. 1 minus u all squared. Then I got the u to the negative half and the du. Then you have to square it, distribute it to get the result. So it's going to be negative 1/2, 0 to 1. Okay, you just square it. That gives you 1 minus 2u plus u squared. Then you multiply by u to the negative half and du. You continue. That gives you negative half, 0 to 1. Okay, multiply inside. So that gives u to the negative half minus 2u to the positive half and the u to the 3/2. When you multiply, you add the exponent. Okay, and eventually you can integrate it. So that gives you negative half integral from, if you integrate it, times it. So that gives you u to the half over 1/2. Okay, and this is going to be a negative 2 u to the 3/2 over the 3/2. And this would be u to the 5/2 over the 5/2. You got to be careful about this 0, 1. This 0, 1 belongs to the u. You can stay with this, change it to the x, and then substitute. If you want to stay with as you are, you have to change this one. Remember what was the substitution that we take? We take the u to be 1 minus r squared. If you put the r equal to the 0, your u would be 1. And if you put r equal to 1, your u would be 0. So it would change from 0 to 1 up to the, okay, this is it, 1 to 0. So this is a point that you got to be careful about this one. Okay, because otherwise your answer would be negative. I missed it on that, the practice, the solution I gave you. So simplify it. So this is going to be a negative 1/2 times it by, switch these numbers or flip it, 2u to the 1/2 minus 2 times 2/3. Okay, plus 2/5 u to the 5/2. Then evaluate from 1 to 0. If you put the 0, we get nothing. Okay, minus, put 1, there is a negative here, make it positive. If you put 1, 2 minus 4/3 plus 2/5. Okay, so that gives you half. Common denominator would be 15. So we get a 30 here, 20 here, and the 6. So that gives you 1/2. Okay. So that was a 15, 30. 15 divided by 3. That give me 5, which is 20. And that give me 6. Okay. So that's it. It's going to be 36 minus 20, which is 16. So we get a 16 over 15, which is going to be 8 over 15. Okay, that's about. On the review, I got negative 8 over 15 because I didn't change this. the numbers. Okay, you are not done. Of course, this is just inside that integral. You go back and your integral is going to be, remember, from 0 to 2 pi, whatever you have to integrate it with respect to the data. So that would be easy. We have some other terms. It's very long problem really. There was another term here. The term was cosine square of the data, and this is sine square of the data. Then you have to continue to get this. It's one problem in your book, in fact. Okay, more to go. You see, you bring the 8 over 15, 0 to 2 pi. Now I'm going to integrate this one. You know that the sine, true sine data, cosine data is sine of the two data. Sine of the two data is going to be true sine of the data, cosine of the data. So this would be what? And this would be sine of the two data over 2 all squared d data. Okay, I'll just substitute. Sine cosine is sine of the two data over 2, and then that gives you the result. And you continue, that's going to be 8 over 15, 0 to 2 pi. And this is sine square of the two data over 4 d data. You pull out the 4, these two would cancel out. You get 2 over 15 integral of the double angle, if you like. Sine square, you change it into the double angle, and then you integrate it. So that gives it 2 over 15 integral from 0 to 2 pi, and that would be 1 minus cosine of the 4 data divided the double angle over 2 d data. We get sine squared, we switch it, and now we integrate it. So that gives you 2 over 15 integral from 0 to 2 pi. If you break this one into the 1/2 minus cosine of the 4 data over 2, now you can integrate it. So the integral is going to be equal to the 2 over 15, 1/2 of the data. Integral of the cosine would be sine minus sine of the 4 data divided by 4, 4 times 2, and to be evaluated from 0 to 2 pi. For the 0 and 2 pi, this sign would be 0, so you get only this portion. Okay, the only thing that you have is 2 over 15 times 1/2 times 2 pi. And if you simplify it, that gives you 2 pi 15, the final answer. Okay, I just wanted to see that middle part. Of course, this is a kind of a long question, but it's nice because in the application problems, you may have to do it in future. But the surface integral on the test is not as long as this one. Okay, and the integral are straightforward, and you'll be able to do it quickly for us. Okay, but remember these type of ideas that you may have to do this, modify your substitution method to be able to take care of that, that extra R that you have. So that was the purpose that I want to explain, to make sure you know it. Okay. So that's one question on the surface integral. Then, of course, verification of the Stokes theorem. We give you one, the situation, and then you have to verify it for us. Okay, this is the one. So that was 25. One question of this type, not as like the one that I gave. So the other question is going to be these two, 27 and the 26. The verification of the both of them is almost the same. So the verification of the Stokes theorem. So I'm going to do the 27 to explain it for you. Okay, we give you one. So again, these two questions are the one that you better keep it and do it at the end. It's not difficult, but it takes time. Okay, so this is it. I'm going to verify this one for you. 27. I think I didn't do the 27 the other day. No. So let's do it so that you know that how you're going to handle it. So that would be the, besides the quiz, two more questions. Surface integral and the verification of the, okay, of the Stokes theorem. So that's it. This is going to be number 27 that I'll explain. Stokes theorem or the verification of the Stokes theorem. We want to verify it. So verify and verify the Stokes theorem. You know that the Stokes theorem is going to be, if you want to find the integral, like I just use this notation that you have in your review, the integral of the m dx or pq, doesn't matter, n dy plus p dz. You are going to show that this is the same as, so this is going to be on the curve C. It's the same as the double integral on the surface of the curl of f done the normal and the ds. This is what we want you to do for the function. So this is going to be the function when the function is f of x, y, z is equal to the, it's going to be easy function to handle, and negative 2x, 3x, and 4y. And this is going to be, is a vector field, and of course the surface, on the surface, in this case going to be kind of a paraboloid, z equal to the 1 minus x squared minus y squared, but z is going to be positive. Okay, so this is going to be the case. So step by step, you are going to find the both parts of the integral and show that I are going to be the same as each other. Okay, my suggestion is do the line integral first because that's easier, and you get the solution, so you know what you expect for the other part. Okay, so for the solution, we go with the line integral first. Line integral. So we're going to find what is the integral of the m dx plus n dy plus p dz over the c. Okay, the c is going to be boundary of that curve that's given to you, and it's going to be the projection of the surface. Okay, so this is it. Your surface equation is this one, z equal to 1 minus x squared minus y squared. Okay, it's going to be your surface. So the projection into the two-dimensional, you take the z equal to the 0. Then in that case, you are going to have x squared plus y squared equal to 1. So the curve are going to be a kind of a unit circle. Okay, so this is going to be the equation of your curve. It's a unit circle, x squared plus y squared equal to 1. And unit circle, you are going to get the parametric form of this one. So this is it. So your x is going to be r cosine of the data, which is going to be cosine of the data, because the unit circle, y is going to be sine of the data. And you can take the z to be 0 if you like, because it's a plane and you want to substitute to get those function parts. Okay, and this is it. So you find the dx. Dx is negative sine of data d data. You find the dy, which is cosine of the data d data, and your dz is 0. Okay. Then we go to the function and you get those. So what's going to be the function f is equal to negative 2x, 3x, and the 4y. So your p function, your p is negative 2x. Your q is, okay, and this is it. Q is 3x, and your the last part, I just use the same different notation, doesn't matter. PQR as usual is going to be 4y. Okay, so you substitute to get the integral. So the integral of p dx plus just the usual notation that we have, r dz over the c is going to be equal to substitute. So you substitute for your p is a negative, okay, p is a negative 2x. Okay, they get it, but just double check these. Okay, p is, what was the p again? And the function, I'm sorry, p is negative 2z, okay? Is a negative 2z, so that's a negative 2z. And that's a negative 2z at the, on your lecture, on your problem. Okay, now substitute. So p is a negative 2z times the dx. What is the dx? Dx is negative sine of the data, d data or t, doesn't matter. Then plus q is 3x, 3x times the dy is cosine of the data, d data. Okay, and the last part is 0. It's going to be r dz. Okay, and the dz is 0. Okay, dz is 0. So again, z is also 0. Okay, remember z is equal to the 0, so that would be 0. So you will end up with something very easy. So the integral is going to be on z, you get the 3x. Okay, we get the 3x just cosine of data, d data. Substitute for x, your x is cosine of the data. So it's going to be equal to the, okay, 3 cosine of the data, d data on the circle. So that give you, you are on the circle, so 0 to 2 pi. Okay, 0 to 2 pi, 3 cosine square of the data, d data. Okay, so you end up with this easy integral. So it's going to be equal to, you bring out the 3, so it's going to be 0 to 2 pi. You substitute for cosine squared, it's going to be 1 minus cosine of the double angle divided by 2 d data. You break it and integrate it. So it's going to be 3/2. Integral from 0 to 2 pi. Okay, that gives you 1 minus cosine of the 2 data, d data. Okay, integrate it. So that gives you 3/2. Integral of 1 is data. Integral of the cosine is simply sine, so it's going to be minus sine of the 2 data over 2. But you're going from 0 to 2 pi. 0 to 2 pi, this the sign would be 0 always. So the final answer is going to be equal to the 3/2 times the 2 pi. So the result is 3 pi. Okay, so with the line integral, you arrive at the 3 pi. So you have to prove that with the surface integral, you're going to get you get the same thing. Okay, any question? So that is the line integral. Usually it's just a substitution to get the result, and that gives you the idea of what is going to be on the other side. So now we go back and we go to that surface integral on the vector field. This would be a question because we give you the surface integral on the, or give you the scalar values function. So this is the possibility that we check the, we check the curvilinear one or the vector field type. Okay, so I did the first one. I'm going to work on this and prove that this is going to be a 3 pi a. Okay, so there you are, going to the original part. So we would like to do what is the surface integral part. Surface integral. That takes a little bit more time to find. So what are you looking for? You are looking for double integral on the S, and this is the curl of the F. Okay, dot N, then the ds. This is the case. So you have to find this first. Okay, so we bring the function again and just try to do it. So what's the function? The function is, this is the function, is a negative 2z, and you have the 3x, and you have the 4y. So you have to find the curl. So the curl of f is going to be just differentiation operator cross f. So you have the cross product. So you have the I, and you have the j, and you have the k. So the operator, this is going to be derivative function component, negative 2z, 3x, 4y. Get this determinant to get your curl. So it's going to be equal to the I types times I cross out the first row, first column. So this is it, derivative respect to the y, which is 4, minus derivative respect to the z, which is 0. Okay, minus a j, same thing. Derivative respect to the y, x is 0. Derivative respect to the z is negative 2. Okay, plus k times derivative respect to the x, 3, minus derivative respect to the y, 0. So you get the 4i. Negative would be positive, that give it 2, but there's a negative sign here, minus 2j, and the 3k. Okay, in vector form, it's going to be 4, negative 2, and 3. So that would be the curl. Okay, any question? No, you have to get you get the normal vector. So the next step is going to be what's the normal. So your equation of the curve is explicit. So it's a z equal to 1 minus x squared minus y squared. You call it g of xy and use the formula that you have. Remember, in this case, you know that you have to have this one. The normal curve is going to be always negative derivative partial respect to the x, comma, partial respect to the y, and 1. It's good to know this one. You don't have to evaluate it. Okay, when the surface is of the form of the g of xy, we take this one. We did this one before. It's not a big deal. You can find it, but it help you. Just differentiate. So the n is equal to derivative respect to the x, that give me negative 2x. So negative would be positive, that give positive 2x. Derivative respect to the y would be negative 2y, negative positive 2y. Okay, and 1. So that would be your normal vector. So you multiply, you get the dot product of the curl and the normal vector, and then you integrate it. Okay, so the next step is going to be, we have the curl of f dot n. So the curl is 4, -2, 3 dot 2x, 2y, and 1. If we do the dot product, it's going to be a function 4 times, this is the 4 times 2x, okay, minus 2 times 2y, and the 3 times 1. So that would be 8x minus 4y, okay, plus 3. So that gives you the function that you are going to integrate it, okay, to get through that that part. Okay, and so substitute this one into your okay, into your surface integral. Then you switch it into double integral on the domain in xy coordinate. Then you'll be able to do it. Okay, so this is going to be the next part. So the next part is we are interested in this curl of f, okay, dot n ds. Okay, so that was a surface integral. So we switch it. So we substitute. We have the 8x minus 4y plus 3. Okay, that's going to be the 1. You know that when you substitute, this would be changed into the, okay, this would be changed into this domain. So we have the double integral of the function 8x minus 4y plus 3. Okay, and this is going to be on the domain in 2-dimensional that we're going to get it. Okay, because we already set everything all right. So we are going to get this, what's going to be the domain? So the surface is like the one that we did for the other side. So the domain in 2-dimensional is going to be unit circle. Okay, so R between 0, 1, data between 0 and 2 pi, and then you just substitute for the x and the y from the polar coordinate, and then you'll be able to do the job. Okay, so the domain, this was, we did that for the other part. I just remind you, z is equal to the 1 minus x squared minus y squared. You put the z equal to the 0, we get this x squared plus y squared equal to 1. So the domain is just unit circle as we did it before. Okay. So, and that's it. So your R is between 0 and 1. You have to go to the polar coordinate, and data is between 0 and 2 pi. Okay, so now you set up the integral. So the double integral of 8x minus, okay, minus 4y plus 3 that we did over here on the domain of A. So would be changed into R from 0 to 1, okay, data from 0 to 2 pi. The function is 8x minus 4y. You have to change it. Remember, 8x was a cosine of the data. Y is sine of the data plus 3 extra r. Then the d data, dr, d data. I just change it to the polar coordinates, okay, to get these numbers. You know, that it's going to be like the other part that we did. So we have to integrate respect to the r. This would be only r squared. Okay, r squared over 2, and then we just, you know, we just take the integral of the rest. Okay, so this is going to be 0 to 2 pi. So we take the integral of 8r, which is going to be 8r squared over 2, and r going from 0 to 1. And then we come back and we take care of these integrals. Okay, so that is going to be the case. Sorry, it's going to be r squared over 2, then the rest. The rest are going to be 8 cosine of the data minus 4 sine of the data plus 3. Okay, this is going to be the leftover. Okay, I just integrating. So if I put r equal to 1, that give me 1/2. So it's going to be 0 to 2 pi. Okay, 0 to 2 pi, I have a 1/2 and the rest. I can pull out that the 1/2 and then integrate it or just multiply inside. Cosine of the data minus 4 sine of the data. Okay, plus 3 d data. Okay, you can multiply inside if you like and integrate it. So that gives you 4 cosine of the data. That gives you 2 sine of the data and the 3/2 and the d data. Now we can integrate respect to the data and do the job. So it's going to be 4 sine of the data, integral of a cosine. This would be plus 2 cosine of the data, integral of a sine, and the 3/2 of the data, evaluated from 0 to 2 pi. Okay, if you substitute, if you put the 2 pi, that give you 0. Okay, so that give us 0. Let me see. I did everything all right, which is what was the situation that we did have over here? Okay. I have the R here, and again, I missed another R like the other day, because your X and the Y are, sorry, Ben, you see your X is R cosine of the data, and the Y is R sine of the data. So there is a R here, and I just missed it. You see, this is going to be R. So I'll have, it takes, you have to check it, you have the solution, of course. Sorry about that, I miss all these R's. So you have to take it from here, separate it, what's the time? Separate it and do I missed this one. You see X is R cosine of the data and Y would be R sine of the data. So you have to multiply this R inside and take this integral. There's going to be just a little bit change to get that 3 pi. It's coincidence that I missed both of them the other day and today. Okay, so I can do it so that you are not going to miss it on the test. Okay, remember when you do here, when I did the polar coordinate over here, this is different from the other part. The other part, it was just a direct substitution. Okay, R of t. So you see the other part, when you substitute directly, because this is your curve, and this is going to be sine cosine data, because R is equal to 1. And when you do the polar coordinate, in the case of the polar coordinate, you have to evaluate the function at X and the Y in general. So your X is going to be R cosine of the data and Y would be R sine of the data. Okay, that's the one that I missed. So I have a little bit of time, so I can do it. So you're not going to make a mistake. So we multiply the R inside and then we integrate it. It takes a little bit more time. So we have the 0 to 2 pi, 0 to 1. If you multiply the R by 1, that gives 8R squared cosine of the data minus 4R squared sine of the data plus 3R. You see, this is the one that you integrated respect to the R. Okay, just make sure you know the difference. And now a little bit more operation, and then you should get the 3 pi. Okay, now integrate respect to the r. It's going to be quite a lot. So that gives you 8r cubed over 3, the first one, cosine of the data. The second one minus 4r again cubed over 3 sine of the data. And this is going to be 3r squared over 2. Okay, then you are going to find it from 0 to 1. Okay, and when you're done, you get the d data. So there's going to be a change in those coefficients that will help you to get the final answer. Okay, if you put the 1, so this is the one that you have to integrate. 0 to 2 pi. So that gives you 8/3 cosine of the data. That gives you 4/3 sine of the data. And that gives you 3/2. Okay, this is going to be the case. Now we integrate this one to get the 3 pi. So now the integral is going to be, integral of a cosine is sine. Okay, that gives you sine. Integral of a sine is a negative cosine that gives 4/3 of the cosine. And this integral would be 3/2 of the data. So this would be 0 and 2 pi. So let's see if we can get it. If you put the 2 pi, this would be 0. Okay. If you put the 2 pi, this would be 0. And this would be 1, so that make it into the 4/3. And this would be 3/2 times the 2 pi. This is when you put the 2 pi 0. If you put the 0, so that's a minus. If you put the 0, sine of the 0 is 0. Cosine of the 0 is 1, so that gives you 4/3 and the 0. So it's going to be conclusion. This would be 4/3 and this would be 3 pi plus 3 pi minus 4/3, which is 3 pi. So yes, you can verify the Stokes theorem. Okay, it must be the same. Okay, both of them is going to be the same. So this is, again, I told you that verifying a Stokes theorem and the surface integral. It's a 2 question that you better leave it and do it at the end. Do all the other first. They are going to be very short. You can do it. And even the one that you have for the verification of a Stokes theorem is not a bad one. It can be done. So do all these problems again. So it's a 13 question. You can miss one. So leave these 2 at the end, and then you'll be fine. Okay, that's it. That's all I have time. So I wish you all the best. Most of you already got a very, very good grade, excellent grade, but you have to get an excellent on the final. So just take your test as soon as possible, and I will grade your quiz. I drop your lowest quiz, so your grade would be ready. And when you're done with the test, I will grade them by Friday. And I post the grade on Friday. Since there is a deadline for the grades, I cannot wait. I have to submit it. So if you have any question about your grade, as soon as I post it Friday morning or early morning, you just let me know if you have anything about the grade or if there's going to be something missing. Otherwise, I will submit it. Okay, thank you. Confirm only required to do 4 questions for, the assignments are just 4 questions. Just check this one. Calculus 3, I always end up with this, that it's a very special course, really. And I know that the people who are taking this course are also special. I enjoy teaching this course every time I do it. It's heavy, but at the end of the day, this is the one that you need for future, really. And it's a quite interesting course. Okay, so thank you and good luck. Okay, let me know if you have any question. You can email me. Okay, bye-bye. Have a good one.